MCT4C, we're at the end. We're doing some review, and we've done quite a bit in Chapter 1, so I thought we would just go over some things. First thing is angles in standard position. So by convention, angles in standard position are where we have an initial arm, where our initial arm would start in quadrant 1 facing in the positive x direction. An angle of rotation goes counterclockwise, and the terminal arm is where it ends. Arm. Theta is the angle of rotation. And it rotates through a point xy such that sine of theta equals y over r. R is the length to the point. Cos of theta is x over r. And tan of theta is y over x. And we got those from opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent when we set that up in quadrant 1. But we can extrapolate that to x, y's, and r's. The other relationship we can remember here is that x squared plus y squared is r squared. Whoops. To find the length of r. There were some special angles that we can use the cheat sheet for, but we can also commit to memory, that come from the two triangles for 45 degrees and for 30, 60, 90. So if you have a triangle with 45 degrees, the ratio of the sides could be 1, 1, root 2. So that the special angles for 45 degrees are sine 45, opposite over hypotenuse is 1 over root 2. Cos of 45 degrees is also 1 over root 2, and tan of 45 degrees is 1 over 1, or 1. The triangle for 30, 60, 90 is in the ratio 1 root 3 to 2, so that sine 30, cos 30, and tan 30, as well as the 60 degree, all come from this triangle. Sine of 30, opposite over hypotenuse, is a half. Cos of 30 is root 3 over 2, and tan of 30 is 1 over root 3. 60 degrees, coming from the same triangle, so I don't commit them to memory. I just draw the triangle real quick when I'm working with these. But we will ask you to solve problems with exact answers using these special angles. 60 degrees is opposite over hypotenuse, root 3 over 2. Cos of 60, adjacent over hypotenuse, is a half. And tan of 60, opposite over adjacent, is root 3. We looked at multiples of special angles. So if you had an angle of rotation, so we're kind of putting the two ideas together. The angle of rotation, say for example 135 degrees, that would be an angle of rotation of 90, 45. So angle of rotation of 135 is related to 45 degrees that we know from our special angles, because that special angle between the x-axis and our angle of rotation is one that we know. So the numbers for sine 135, cos 135, and tan 135 will be the same as the numbers for 45. So let's just go back and grab those numbers, 1 over root 2, 1 over root 2, and 1. But in that quadrant, by x value is negative. So cos, which is x over r, will be negative. Tan, which is y over x, will also be negative. And sine is positive because it's y over r. Both of those are still positive. We can also remember that sine is the positive one because of the cast rule that tells us that the only thing in that quadrant, or an angle of rotation of 135 is in that quadrant, would be sine. We also did, you know what, I'm going to add a slide in here. Something that we did was something like an angle of rotation through a point. So if you had an angle of rotation through the point minus 2, 3, find the three trig ratios, and find theta. So if we have an angle of rotation that is through the point minus 2, 3. Well, first of all, I'm going to kind of eyeball where minus 2, 3 is. It's in quadrant 2, and it's about right there. So I would have an angle of rotation that would come around through here. And that terminal arm would pass through the point minus 2, 3. So there is my angle of rotation. I know my x value and my y value. I can find my r value, which is the length to that point, r. I can find my r value by doing x squared plus y squared, which would be minus 2 squared plus 3 squared, 4 and 9, r squared is the square root, or sorry, is 13. R itself is the square root of 13. So if I first of all want the three trig ratios, sine of theta, cos of theta, and tan of theta, I know that sine of theta is y over r, cos of theta is x over r, and tan of theta is y over x. So here we go. My y value is positive 3 over root 13. Cos is negative 2 over root 13. And y over x would be 3 over negative 2. You can put that negative in the middle, at the bottom, at the top. It doesn't matter. I want to find the angle. So I'm going to use this trig ratio. If I want to find theta, I use second function cos minus 2 over root 13. Which is about 123.7 degrees. All right, next slide. Then we did solving triangles, so some more practical. SOHCAHTOA, which we've done for a long time, sine law and cos law. So our order of operations would be to look for a right angle triangle, which you can also use Pythagorean theorem on. Then we would look for the sine law, where you would need to have an angle side pair. And be careful to watch for the ambiguous case. Lastly, we use the cos law when we have three sides or side angle side. We would need to use the cos law. For more practice, I have some questions here. We're going to find exact values for sine 30. It's a half. Cos of 45 is 1 over root 2. I'm getting those from those special triangles we had on the last slide. Tan 60 is, I have to look that up, root 3. Sine of 210 is related to, I need a diagram. So 180 plus another 30 degrees is 210. So I know that that is related to the angle 30. I know that sine is going to be C-A-S-T. Sine is going to be negative here, related to 30 degrees. I know sine of 30 degrees is a half. So sine of 210 is negative a half. Cos of 240, I would draw it. 240 is 180 plus 60 degrees. So the angle is 60 degrees, the angle that it's related to. I know that cos of 60 degrees is a half. And in that quadrant, cos is negative. So the cos of 240 is negative a half. Tan of 300. Well, let's do a different color. Tan of 300. First of all, I want to kind of eyeball it. 300 degrees is all the way past here to there, with an angle between the angle of rotation and the x-axis of 60 degrees. So tan of 300 has the same numbers as tan of 60, which is root 3. And then I need to be careful I have the right sign. So with the cast rule, tan is negative in that quadrant. So negative root 3. 2 uses the same special angles, but we're going to use them to create a simplest expression. Sine of 30 is a half. Cos of 60 is also a half, plus cos of 30 is root 3 over 2, and sine of 60 is also root 3 over 2. So we're going to replace exact answers, and we're going to simplify as far as possible. A half times a half is a quarter, plus root 3 over 2 times root 3 over 2 is root 9, or regular 3 over 4. 1/4 plus 3/4 is 1. Cos 45 is 1 over root 2. Cos of 135 is negative 1 over root 2. Take away sine of 45 degrees is 1 over root 2 times sine of 135 is positive 1 over root 2. 1 over root 2 times negative 1 over root 2 is a negative a half. Take away 1 over root 2 times 1 over root 2 is a half. We get negative 1 for our answer to this one. A point, 3, 1, is a point on the terminal arm of angle theta in standard position. Find sine theta, cos theta, and tan theta. So in standard position, I am rotating counterclockwise, and we are going through the point 3, 1. Well, I don't have to go very far. That would be my angle of rotation here. This is my terminal arm, and it goes through the point 3, 1. I would like to find my r value. R squared is x squared plus y squared. 3 squared plus 1 squared is 9, and 1. R is the square root of 10. So for my sine, cos, and tan, I need y over r, x over r, and y over x. You should have all of these on your blue cheat sheet. Y over r would be 1. And my r value is root 10. My x value is 3. R is root 10. And lastly, y over x is 1 over 3. Number 4. Angle theta is in quadrant 3, and tan theta equals 3 over 4. So in quadrant 3 is there. And tan of theta is 3 over 4. So if tan of theta is 3 over 4, I have a y and an x value, because it is y over x. So if my y value is 3 and my x value is 4, but I'm in quadrant 3, that means both of those are actually negative numbers. So x is negative 4, y is negative 3 in that quadrant. So 1, 2, 3, 4, 1, 2, 3. It would look like that-ish. Angle of rotation into that quadrant. And I want sine theta and cos theta. For sine theta and cos theta, I need r. y over r, and x over r. So to find r, I have to use the Pythagorean relation. Minus 4 squared plus minus 3 squared is 16 and 9, or 25. So my r, which is always positive, is the square root of 25, or 5. So my numbers, y is negative 3, r is always positive 5. Cos theta then would be minus 4 over 5. Solving for theta. And probably the question would have that at the top. We're looking for two possible answers for theta. My first answer for this problem is second function tan, or the inverse tan of that decimal. But remember, there are two possible answers where tan is positive. So I make a little note of the cast rule. I know one of my answers is going to be where tan is positive here. Tan is also positive here. My calculator will give me one of those two answers, and I need to find the other one. If I use my calculator, I will get about 48 degrees. That's in quadrant 1. I know there's another answer in quadrant 3. When I have a tan ratio, to get your second answer, we do 180 plus the first answer. And that is also on your blue cheat sheet. So the second possibility when I add those together is 228, which is indeed in the third quadrant. Where is cos theta negative? I do draw a diagram every time with my cast rule. So the letters stand for where things are positive, so I know that the cos is not positive or negative here and here. So that's where my two answers are going to lie. My calculator will give me one of them, and I will need to find the other. If I type second function cos of negative decimal 5446, my calculator will give me 123 degrees. I know that that is in quadrant 2, so I need to find the quadrant 3 answer. When we have a cos ratio, to find your second answer, it's 360 minus the first answer. And we will get 237 degrees. That is in quadrant 3, so we're good to go. And lastly, sine theta is positive 0.9877. Sine is positive in this quadrant and in this quadrant. So the first answer is just trusting your calculator, 0.9877. And calculator gives me 81 degrees. And for sine, and we use this one often, for our second possibility, we subtract from 180. So our second possibility, which is in quadrant 2, is 99 degrees. I'm going to leave the solving triangles because you've had lots of practice with that before, but where you're finding lengths and angles using SOHCAHTOA and Pythagorean theorem, cos law, and sine law. I have a practice test for you. And we also have already looked at the Chapter 1 review, but that would be some excellent questions to add as well.